Okay, quick note before we get into the assemblies is that warning that kept popping up, and the reason that I was getting the mod diameter rather than the actual diameter symbol is the warning was telling me that in my SolidWorks 2019, because I've had multiple versions installed or updated and uninstalled and updated and all of that, the 2018 folder basically lost those two files. So the GTOL symbols are where we're picking up the definitions for the diameter, and the properties are our list of properties. So pretty much want both of those. And so under the my System 19, I created a properties, because as we create a custom properties or modify the existing, I'm going to want to put all of those in that common area on my cloud. So basically grab these out of the program data SolidWorks, 9 levels deep kind of thing, copy both of those files into the properties, and then now when I go to configure that feature, after it catches up, figures out what it's doing, and configure the feature, now I'm not going to get that warning each time. And let's do the double check, maybe the cut extrude, and now I see the diameter symbol in that mix. All right, so the spacer plate part is going to come in as configuration regardless. I did not create any separate files for it. The pegs we can do as an example with this this first item. So figure 5-3, we're going to have a quad, and then the rest of the pieces. So, oh, did I not create a quad? A 1x4. All right. Well, I guess we can go back and add that to the mix. So there's the one. They hid it on me. Ah, there it is. I knew that there was a quad definition. I just didn't. I didn't connect it. All right. So one more quick addition to get back into the design table. This actually works out pretty good. Then to get into the design table, I'm going to right-click, and the edit feature is what loads that embedded window. Or I'm sorry, edit the table. Edit feature takes you back to the original property manager. Edit table will load the embedded, and edit table in new window will launch Excel and bring it out into the mix. So it's kind of weird, the save and some of the other things that we do. And then a couple of quick notes. I'm going to insert a line, but be careful anytime there's a gap. So if I created one here, the SolidWorks will only read to that line and say anything below it doesn't exist. You created a gap, you're doing something different, I don't care. Alright, so if I insert, then this was still in the spacer quad range, so we will do a Control-C and a Control-V. Don't know that I saved anything there on the typing. And then this would be a 30 millimeter by 120 millimeter. And so I believe, well, let's do the copies again. So these I definitely do not want to try to enter manually. Alright, so since we went on my description, I'm doing height and width, and then height and width. If I can reverse, I was thinking I could pull those out, and in the full it should let me move them, but let's go ahead and cut and insert. All right, so height and width, and then we will try again, cut and insert, so it's height, width, height, width. Alright, so that means the 2x2, the 2x3, and then the height is going to be 30 by 120. Oh, I didn't get the tab in there, I hit caps lock. Alright, so 120, caps lock doesn't help me. and then 1x4 on our pieces, and since it went ahead and added the suppression state as unsuppressed, then I'll just go ahead and copy those in, and we'll set it into the mix. So just to be on the safe side, I will save it and then close it, and I should still get the confirmation that it created the spacer quad, and we want to double check that it is working correctly. Oh, didn't get something in there. So I thought I put in the 30, no, I put in 60, didn't I? Alright, so in this case, now the pink, or the magenta, is showing me that these items are being driven externally by the design table. And if I come back to like sketch 2, I don't see any of these dimensions in pink, so mainly the extension lines is what I'm looking at. None of those are being driven by the design table, and when we come back to the pattern, not really getting anything out of that too. The pretty much the instance count is the one that's being picked up. So I want to leave that one active, treating the spacer plate, in this case the spacers, as the initial item. So I'm going to go ahead and close, and it didn't ask me to save, so it should be in pretty good shape. Let's go ahead and we'll bring this down. Alright, so to start the assembly, we're going to bring in the items, and recommendation is always that you bring in one item at a time, put it into position, and then bring in the next item. If you bring in all of these parts, good luck with that. Not my favorite thing to do, and I have had plenty of assemblies that I've corrected or modified where we did a lot of hiding, we did a lot of suppressing, just so it wouldn't freak out as bad. Alright, so everything's a line to line, so I don't have an assembly. So I'm going to go back to the tutorial and pick up an assembly. And first time we do this, I'm probably going to go just kind of do a quick check. I don't usually turn the origins on for the assembly. We're in kind of a trimetric view. That all looks pretty good. If I think of anything, probably the units. If we were to go millimeters, grams, and seconds, and then come back and edit the document units, 2 decimal places on the millimeters, 3 on, don't really need to be that custom. So we'll do a save as to the template, and it goes back to my location. And so if I do assembly, still have those caps on, and set it to millimeter, then kind of in that same vein, I could go ahead and set 1 to inches. Inch, pounds, and seconds, which is over. We want 3 decimal places on our inches, 2 decimal places on the millimeters. Notice it's only changing the top, so I'm going to grab both of those, hit OK, and then I can do a file with a save as, and it's going to default to the document template, and then I can tell it that it is an inch. Right, at this point, anything that I put into the DOT is going to get saved with the DOT, so I actually want to see those popping up in my templates. So we're going to pick an assembly millimeter, and if I find more things or something that's going to assist, then I will just add it to the template. Alright, so by default, starting command when creating new assembly, it's going to ask for the first item. Doesn't always have to bring that in. We need to do a little navigating, find my assignments, and then the first item is the spacer plate, and the configuration spacer quad, and it's showing me the configuration name and then its description. Alright, so when I open that, if we just go to the check mark, it's going to come in origin to origin, origin of the part to the origin of the assembly. I want to rotate this. If I look at the triad, and I can see that I want to rotate this about X, and then we come back. One of the things to check will be, did it go origin to origin? So origin of the part, if I expand this out and be able to identify the origin, it's at the top. Not really concerned about that one. Just means that I kind of flipped it over, and the origin of the assembly is at a different location. That's perfectly acceptable until we start to rotate and it's floating out in space quite a ways. If I'm not worried about center of mass in relation to the assembly origin, then I really don't need to do anything. But early and often is I will right click and float, and then we are now responsible for positioning this. So at this point I am moving the part. If we had the let's turn the origin on real quick. We have the origin of the part and the origin of the assembly. If I'm moving, so left click, hold down, and I'm moving the part around, then I can tell that I'm manipulating the part. Let's see, is it the control? Nope. Let's see, which one am I looking at? If we rotate or we pan, if both are moving, the origin of the assembly and the origin of the part with the part are moving, then we're doing the pan, or we're doing some kind of rotate. So that'll help keep your perspective. And so I'm going to go without the net of the origins, and so I want a face. Now let's see what happens if I pick that face and I go to the top. We'll see if it reverses. Alright, so if you don't get the little pop-up, then we're going to be able to expand out. We're going to see the mates. Alright, so if I right-click and I want to make decisions as I go, then I can flip the mate alignment, and that'll pull the part around to where the bottom of the part and the top plane are in the same location. Alright, so Control 7 gets me back to my view. I can do a quick check of the origin. So maybe that face and the front plane. Alright, so my hierarchy, if you watched in any of the previous assembly videos, my hierarchy will be plane to plane or plane to face to plane, whichever. And then we would go further down and say cylinders face to face, and working down the hierarchy, then edges, and last is points. Alright, so there's going to be times where you're going to use edges, but again, it's more habit, more do I really want to fight each of the individual points and end up with all of those mates. Alright, so we'll talk about the 6 degrees of freedom. Alright, so don't know why that's creating such a... And again, I'm doing more on this first one of, I want you to see this little pop-up. If you're not getting that little pop-up, count to 3. Click on your 2 items and then give it a pause so that it can catch up. And then that's going to be your most efficient, fastest way to set the mates. Alright, we have the first item in. Hardware and fasteners is a general rule, unless they are providing some kind of location. Hardware fasteners come in last. So the bracket would be next. And so we'll do one bracket with the let's go with the insert component, and we'll make it an existing part. So let's bring in the C bracket, and it will open, and we'll just kind of rough position it. Its orientation is okay, otherwise I would do the rotates. Let's see, where is that little, we have the graphics preview, which is showing us the item, and then the rotate context toolbar is this little guy, and that will allow us to position it before we start the mates. Alright, so that gets it close, and actually we are pretty close. Sometimes they're a little further out into to space. And then we have to start making decisions. So one of the advantages of the configurations is if I had accidentally brought in the L bracket, I would have to come over here and let's see if I can find it. Somewhere there should be a replace. Oh, we have to hit the down arrow all the way at the bottom, and then just off screen is a replace components, and then we tell it to take this one out, pick the other one on down the on down the line. It's a little more complicated. It's certainly doable, but it's not as convenient as what we're going to see with the configured bracket. So this one's going to have a mix, or maybe the next one will pick up the configured brackets. Alright, so this is where you're going to get really used to the middle mouse button rotating. And I have a little drag in the graphics card still. We had that issue with the mouse and the graphics card where I was getting really slow rotations, and I want to move much faster than that. So we're going to do the same types of things that we do in the sketch. Select, Control, Select, and then I can go to coincident. The other thing, by pre-selecting, if I go over to the assembly, I can always come up to the paperclip, and the paperclip's going to give me a few more selections, or a little more graphic selection. And since you probably don't recognize the coincident, the parallel, this is probably going to be your preferred method. And like I said, I still want you to see that bar, and if you hover over with the tooltip, coincident is that those faces are going to share that plane. Setting a distance, setting an angle. A lot of times we'll reserve parallel or perpendicular. And then the mate alignment is, right now we're in the correct orientation. If I needed to rotate this over for whatever, then I could flip the mate alignment. So first we're going to go coincident. And then my preference, well, let's do the first one. Let's see, that's going to overlap that way, so that really doesn't give me a position. My preference would be to go the whole location to the whole location. Alright, so we've set a couple of our degrees of freedom, and on the preview it's showing me concentric, so cylinders are concentric, sharing the same center. And we're not able to move back and forth, front to back, left to right, up and down, front to back. But we still have rotation. So our 6 degrees of freedom are movement linear across X, Y, and Z, and then also rotation about X, Y, and Z. If we control all 6 degrees of freedom, then we have fully stabilized this part. There are times where we want dynamic, in which case we leave one of those items just because we do want it to be dynamic. We want to see it move. Alright, so the choice here would be, do I leave it coincident? Well, looking into my design intent, it could happen that this would need to grow or shrink, in which case the coincident isn't really my best choice here. The staying coincident face to face is good. The concentricity between is going to stay on center. But if I go to parallel, that means that in certain circumstances, if this was off by a little bit, it would still allow the solution. It would still allow for the correct building of the part, even though I made that change. Now, if we were error checking, I would want to leave coincident, and then it would tell me, hey, you grew the part, you did something to it, and now it needs to update. Alright, so since my fingers got ahead of my mouth again, let's undo that. We have instance 1. I brought in instance 2 without even thinking about it as a habit. So that one was first we did the insert component, and we can always find that existing part in assembly. We can always come over to the insert components. Once I have an instance of a part, then I can hold down the control button, left click and drag from the feature tree is usually my preference, or I can left click and drag from the work area on the part and drag in another instance. Alright, so that takes a little bit of practice, and then at some point it becomes habit. Alright, so same thing, I'm going to go concentric this time. and notice it moves up and down. It can't move left to right or front to back, but it can rotate and move up and down. That's what the concentricity is doing for me. It's checking the alignment of those two holes. I want to make sure that I'm on the edge, or on the faces. I'll stay away from the edges. I lost my little pop-up there, so if I come over to the paper clip, it's going to go to coincident, and then I accept. And as long as I am in the mate property manager, then the little blue box is up, then I don't have to hold down the control button for my selections. Alright, so I'm going to leave that one at coincident. It's not going to help or hurt. Alright, so same thing, I could bring in another spacer plate to cap this. Or we'll go over to Insert Components, because we have to have a bunch of ways to do everything. Alright, that's interesting. I did not expect that one. And we're going to bring in another spacer plate. It's still in the correct configuration. So we'll open, and I'm going to rotate it about X to get it into position. And then I can kind of mix the items if I want. So concentric, and if I'm checking for the alignment, this is going to move up and down and be able to rotate again. And then we go concentric. That would let me know if there's any change in the depths. And so this gets into, we have enough information now that things like the physical properties, the laws that we have to live with, don't necessarily apply here. All right, so two objects can occupy the same space. If we have things like gravity, well, it's not falling to the top plane. So we're responsible for the objects occupying the same space, the gravity, if it needs water, hydraulics, electricity, pneumatics, any of that falls into our realm. All right, the software is not going to tell us if it's not there. All right, so Control Select, rotate over, hit coincident. That gives me the two mates. All right, so this is showing me the instances and how many, basically the order that I've brought them in this case. I can reorder so that the spacer plates are together and the brackets are together. It went from 1 to 3 because I drug that first one in, and they're always going to increment values. It's not ever going to go back and say, oh, you did away with 2, we'll bring in, another 2. No, you had 2, you deleted it, or you undid it, and it is now at instance 3. Alright, so let's go ahead and save this, and we'll let it rebuild and update and make sure it has all of the same items. So we are Assembly Ch5-3, and I'll go ahead and hit save. Alright, so next is to bring in the pegs. All of our pegs are 10 millimeters and 10 millimeters for the thickness, give me 20 millimeters. We did the drag and drop for those two, so let's just go Insert Components. And I try to float around a little bit just so you see the different options. All right, so this one is building without a lot of the whistles and bells, mainly the configurations, or we will get into mate references here in a little bit. All right, so that one didn't quite mix. All right, so even though it goes to the top, I can accept it. And then we will go to coincident, and that puts the peg in place. And then same thing, if I picked a 10 by 20 and I decided I needed a 10 by 30, I would have to right click, and way down on the list we would get to replace components. And I'll show you that real quick. This is the component to replace, and then we would browse to the 10 by 30, and then it would have to check the mates, and then it kind of goes through this multi-step process to do that replace. All right, so in the next grouping, where we actually take advantage of those configurations, we'll see a slightly different process. All right, so within the mates, the only thing, if I had the origin turned on, I would be able to see that this peg rotates, and that's the only thing that's keeping it from under defined. So a couple versions ago, under the concentric, was added that we can lock rotation. that will cause it to go fully defined, and we don't really care if it rotates because it's just a fastener. And then we'll go to the next, and if I drag and drop, well, there's no real mate reference there, so I can bring it in with the control select, set it to concentric. I don't see that that pop-up. I think when it's on the mate property manager we get that, and then coincident. So worst case, if I have to expand that out and right click on the concentric to tell it to lock rotation, that's fine. Alright, for the next one I'm going to open up the peg. So I can open these files from the work area or from the feature tree. And let's tile these horizontally. And another method of bringing the items in is to click on a face, and then as I drag into the assembly, it's going to infer that coincident mate, or concentric mate in this case. And then this time I got the lock rotation. It was either there and I didn't see it, or the graphics card didn't pick it up, but we'll go ahead and accept. Well, it didn't infer the mate, so I guess that was part of it. Alright, so make it coincident, and then now I have the same basic result. Alright, and then the last one is, well, I think there is, from the File Explorer we can drag and drop, and that would be very similar to coming over here to our open documents, or documents that are open in memory. So there is the 10 by 20 peg, and so I can drag straight from there, and I would like for it to go to the mate, but it doesn't have that information yet. Alright, so we'll set to concentric, and I will set to coincident. Didn't see it pop up again, so let's go ahead and set to coincident. And then I need to pick up the peg, so I'm going to go to that instance of the part, expand it out, right click, and set for lock rotation. Alright, so that gives us our first assembly, and we go through that process. It's a systematic step-by-step, and when you encounter problems, you stop, you correct, you analyze and diagnose and fix, and then we come back to the next item. Alright, so we'll keep on going the assemblies, and we'll get a little more sophisticated, a little more complex as we go.